Okay, this is drill 3, and on this one, you're adding like terms, which means you have to find out if the three terms in this polynomial are like terms, which means they have the exact same exponents on the exact same letters. All right, so you can't really tell right now because they all look different, but if you simplify each one, you can figure it out. The first one is already as simple as it can be. It's 3x. The second one has all kinds of things in the numerator and denominator. The 2, it's in the numerator. There's not really anything you can do about that. X squared, and then x to the negative 3. The best thing to do right here is to just go ahead and combine the things in the numerator that you can and combine the things in the denominator that you can, and then figure out what to do about positive and negative exponents. All right, so in the numerator, you've got 2x squared, x to the negative 3. When you multiply x squared times x to the negative 3, you are multiplying like bases, x, and you add the exponents. 2 plus negative 3 is negative 1, so this is 2x to the negative 1 in your numerator. That's all there is. That's all you can do. You can add the exponents on the like bases, that's it. The denominator, there's nothing else to do. They're not like bases, so they just stay the way they are. So in that step, all I did was just add the exponents on those x's. Now I'm going to go ahead and deal with this x to the 0 power, which is 1. All right. Now, again, I got 3x here. Over here, I'm going to go ahead. The y to the 0 is 1, so x to the negative 2 times 1 is just x to the negative 2, so the denominator doesn't really change. It's just x to the negative 2. I'm going to move that x to the negative 2 up to the numerator and change the sign on the exponent. So I'll have 2x to the negative 1, x to the positive 2. I just took this and moved it up, changing the sign on the exponent, and then I've got that minus 1 over there. So I've got 3x plus, now I've got like bases, add the exponents, negative 1 plus 2 is just 1, so 2x, and then that minus 1 is still sitting there. Now I have two like terms. These two terms can be added because they have the same exact letter with the same exact exponent, x to the first. 3x plus 2x is 5x, and then the minus 1 is still just sitting there. All right, number 2, again, you've got all this stuff to figure out what's going on. So the first thing I would do would be to combine anything that you can in the numerators and denominators. Now, in the first two, you can't really combine anything in the numerators and denominators because they're all different letters. So for the first one, for the first term here, I'm just going to move that z up to the numerator and change the sign on its exponent. Right now it's z to the first when it's in the denominator. If I move it up to the numerator, it will become z to the negative 1 because you change the sign on the exponent when you move a variable either from the numerator to the denominator or the denominator to the numerator. Your reciprocal, change the sign on the exponent. All right, so the first term in this is 5x squared y z to the negative 1. The second term here, this one, again, there's z, y, x. There's nothing you can combine, but you can move that x to the negative 2 from the denominator up into the numerator and change the sign on its exponent. So this is 3z to the negative 1y. Now move the x to the negative 2 up, and it becomes x to the positive 2. And then the last thing here, I've got x times x in the numerator, so I can make that x squared. So I'm just going to take a step to go x squared, y squared z over yz squared. Now you notice I didn't try to do several steps at once because sometimes that can be dangerous. You don't want to do several steps at once if you are getting the wrong answer. It's not a good idea to wait to save time by getting the answer wrong. All right. So this first term, it's already in alphabetical order. There's really nothing else I can do to make it clear what's going on there. Second one is not in alphabetical order, so I'll just go ahead and put it in alphabetical order so I can make sure I'm seeing the like terms. So they all look the same. So x squared y z to the negative 1. I can already see that the first two terms of this polynomial are like terms. They both have x squared y z to the negative 1. And then this last term here, I can now move the y and the z squared up to the numerator and change the sign on their exponents. So 7x squared y squared z, move the y up from the denominator, it becomes y to the negative 1. Move the z squared up from the denominator, it becomes z to the negative 2. All right, First two terms, can't really do anything to change those. They're already as simple and orderly as they can be. Now the last term, I've got x squared. There are no other x's there, so that's 7x squared, and then y squared, y to the negative 1. When you multiply like bases, you add the exponents. 2 minus 1 is 1, so it's just y to the first. And then you've got a z to the first and a z to the negative 2. 1 minus 2 is negative 1, so it's z to the negative 1. Now you've got them all looking exactly alike. They all have all their letters in the numerator, and you can see they're in alphabetical order. Now I can look at them and make sure that they are like terms. They all three have an x squared, they all three have a y to the first, and they all three have z to the negative 1. So they are like terms. They can be added and subtracted. So 5 minus 3 is 2, plus 7 is 9. So 9x squared y z to the negative 1 is the answer to that problem. If you are very careful not to make any mistakes with your adding and subtracting, if you take the time to do all those steps, I mean, it didn't take forever, but it really saved a lot of confusion or wrong answers. All right, the next one, we're going to do the exact same thing. The first term, xa, is as simple as it can be. We could put it in alphabetical order if we want. All right, the next one, I can bring up the things from the denominator into the numerator, changing the signs on their exponents. So 3x squared a cubed, and then bring the x up from the denominator. It's x to the first, so it becomes x to the negative 1. Bring the a squared up from the denominator. It becomes a to the negative 2. Now, on the last term, I've got 2x over a to the negative 1. Just bring that a to the negative 1 up to the numerator. It becomes a to the positive 1. All right, so my first term, ax. My second term, I'm going to add the exponents on my like bases. So I'm multiplying x squared times x to the negative 1. Add 2 minus 1 is 1. So that is going to be 3x to the first. A cubed, a to the negative 2. 3 minus 2 is 1. That's just a to the first. Plus 2 and xa. Now I'm just going to rewrite it with everything in alphabetical order just to make sure I'm not making any mistakes. And they're all ax. A to the first, x to the first. Which means I can just add them all up. 1 minus 3 is negative 2. Plus 2 is 0. So that answer is just 0. Taking your time, being organized is super, super, super important. All right, same thing here. First term here, we're going to move everything up to the numerator. So we've got a, m, p to the negative 1. I'm going to move that m to the negative 1 up to the numerator. It's going to become m to the positive 1. Second term, I've got 3 a squared, m squared. I'm going to move that p up. It's p to the first in the denominator, so it's going to become p to the negative 1 in the numerator. The a in the denominator is a to the first, so I'm going to bring it up. It's going to become a to the negative 1. And that's everything. The next term, you've got 5pa. And in the denominator, you've got m squared. Bring it up to the numerator. It becomes m to the negative 2. All right. Now I'm going to add add the exponents on my like bases. So first term, I've got a m. It's going to be m squared, and then p to the negative 1. Second term, I've got a squared, a to the negative 1. So 2 minus 1 is 1, so a to the first. And then I've got m squared, p to the negative 1. And then here I've just got, these are all different, so I'm just going to go ahead and put them in alphabetical order. A, m to the negative 2, p. Go back, put everything in alphabetical order. I've got a, m squared, p to the negative 1, minus 3a, m squared, p to the negative 1, plus 5, a, m to the negative 2, p. Oh, guess what? They were already in alphabetical order. Oh, well, I just repeated the same step twice. That's not a big deal because be as careful as you can be. All right, the first two terms are like terms. Last term is not the same because it has an m to the negative 2, and these first two terms have m to the positive 2, so they're not the same. All right, so am squared p to the negative 1 minus 3am squared p to the negative 1. So 1 minus 3 is negative 2. 4am squared p to the negative 1. And then the 5am to the negative 2p just sits there by itself.